Hey y'all, how do you do?
I'ma flex on my ex, flex on the hoe. You still be in my head, so I'ma let you know. I realize how much I want you when I let you.
Welcome back to Olympiad Question Bank. You know those tricky problems that really test your understanding? That's what we love to tackle here. Today, we're diving deep into the 3 toughest arithmetic progression problems that can twist your brain. But don't worry, I'll break them down step by step just like we always do. Remember, the goal here isn't just to solve, but to understand. We want to build that intuition, that ability to see a problem and know exactly what tools to use. If you're preparing for Olympiads or just love a good challenge, this is your video. So grab your notebooks, pencils ready, and let's get those brains firing. Here's our first question. The pth term of an arithmetic progression is q, and the qth term is p. What is the first term and common difference of this arithmetic progression? Alright, sounds confusing, right? It's like a word puzzle with numbers. But don't worry, we've got this. Let's untangle it. We know the general formula of the nth term in an arithmetic progression is a plus n1 d. This is like our map, our guide through the problem. Remember, A is our starting point, the first term, and D is the common difference, the steps we take on our arithmetic journey. Let's apply this formula. The pth term is Q, so a plus P1D equals sine Q. Call this equation 1. We're just plugging in what we know, making sense of the problem step by step. Similarly, the qth term is P, so a plus Q1D equals sine P. Call this equation 2. See how we're building a system of equations? This is the key to unlocking these tougher problems. Now, subtract equation 2 from equation 1, a plus P1D, a plus Q1D equals sine QP. We're using our algebra skills here, and look, things are already getting simpler. This simplifies to PQD equals sine QP. Wait, look closely, both sides have the same numbers but opposite signs. This is a huge clue. It tells us something important about our common difference. So, PQD equals sine PQ. Divide both sides by PQ, and we get D equals sine minus 1. Aha! The common difference is negative, meaning our sequence is decreasing. Now plug D equals sine minus 1 into one of the equations. Let's use equation 1a plus P1 minus 1 equals sine Q. We're substituting to find our missing A, the first term. That gives A P1 equals sine Q. So A equals sine Q plus P1. And there we have it, our first term. Boom, final answer, first term, a equals sine Q plus P, 1. Common difference D equals sine minus 1. We cracked the code. Remember, it's all about breaking down the problem, using our formulas, and looking for those key insights. Now, are you ready for the next challenge? Let's move to the second brain buster. Question 2. The sum of the first n terms of an arithmetic progression is 3n squared plus 5n. Find the arithmetic progression. This type is classic in Olympiads. It's all about connecting sums and sequences. Step 1. Understand the formula. We're told the sum of the first n terms equals 3n squared plus 5n. This is our starting point, the information we need to unravel the arithmetic progression hiding within. We know the formula for the NTE term is Tn equals sine Sn, Sn1. This formula is super powerful. It connects the sum of terms to individual terms. So, let's plug in Sn equals sine 3n squared plus 5n, Sn1 equals sine 3n1 squared plus 5n1. We're substituting to find the sum of the first n1 terms. Let's expand that n1 squared equals n squared minus 2n plus 1. Remember those perfect square expansions? They pop up everywhere. So Sn1 equals sine 3n squared minus 2n plus 1 plus 5n minus 5 equals 3, n squared minus 6, n plus 3 plus 5, n minus 5 equals 3, n squared minus n minus 2. See how simplifying keeps things manageable? Now subtract Tn equals sine Sn, Sn1 equals sine 3n squared plus 5n, 3n squared minus n minus 2 equals sine 3n squared plus 5n minus 3n squared plus n plus 2 equals 6n plus 2. We found the formula for the nth term. So, the nth term is 6n plus 2. This is a huge step. We're getting closer to revealing the entire sequence. Now let's find the first term. Put n equals 1, t1 equals sine 6, 1, plus 2 equals 8. The first term is always our anchor. Next term, t2 equals sine 6, 2, plus 2 equals 14. See the pattern emerging? We're adding 6 each time. So the arithmetic progression is 8, 14, 20, 26. With common difference equals 6. We did it! We cracked the sum clue and found our arithmetic progression. Done! That wasn't so bad, was it? Remember, formulas are our friends, and a little bit of algebra goes a long way. Now let's hit the final and trickiest one. Are you ready for the ultimate challenge? Chapter 3. Find the position. Here comes the last monster. Which term of the arithmetic progression 7, 13, 19, and so on will be the first term greater than 1000? This one requires a bit of a strategy, a way to think about the problem. Let's break it fast. Here, first term a equals 7. Common difference d equals 13 minus 7, which is 6. We quickly identify our key players. We want the smallest and such that a plus n minus 1 times d is greater than 1000. We're setting up an inequality because we want to go beyond 1000. Substitute values. 7 plus n minus 1 times 6 is greater than 1000. Plugging in keeps things organized. N minus 1 times 6 is greater than 993. Simplifying, one step at a time. Divide by 6, n minus 1 is greater than 165.5. Getting closer to isolating n, our target. So n is greater than 165.5, almost there. But remember, n represents the position in our sequence, and positions are whole numbers. The smallest integer more than 165.5 is 167. We round up because we want the first term that crosses the 1000 mark. So 167th term will be the first term greater than 1000. We found it. The 167th term is our winner. Quick tip, always round up when you hit a decimal in such questions. This is crucial in these types of problems. We don't want to be one step behind. And there you have it. We conquered the final monster. Remember, it's all about understanding what the problem is asking, using the right tools, and being careful with our calculations. That's it, champs. 3 of the toughest arithmetic progression problems cracked like a pro. Remember, these problems might seem daunting at first, but with practice and the right approach, you can solve anything. If you learned something new today, hit that like button and subscribe for more brain-boosting math puzzles every week. And don't forget to share this video with your friends. Let's spread the math love. Comment below which topic you want next. And remember, math is not about memorizing, it's about playing smart. Keep practicing, keep challenging yourselves, and I'll see you in the next one.